Today we're going to continue studying integration, and we're going to find the area of the circle. So we're going to do it by two methods. First one is more geometrical, and the second one is going to be more, actually three methods. And the second and third will be more like integration. So I'm going to be using GeoGebra. And so I have a circle. I have the origin is 0, 0, okay? And here I have a circle. And now I'm going to do a polygon with these 3 points, okay? Actually, these 2 points and one here. And so over here we can see the area, the circle, and it is 50. And my error, so what is happening here, that I have my triangle, and it says that the area is 50 and my error is 29. Okay. And when I begin to increase the sides, because here I have 3 sides, it's a triangle. But let's say that now I have 4 sides. Okay. So now my error is 18. And my polygon, the area of the circle is 50. My polygon is 38. Therefore, the error is 12. And more sides to the polygon, the error gets lower and lower. Okay. And so what is the area? So here we have the triangle. The area of this triangle is base times height over 2. Okay. Let's say that now I have 2 triangles. Okay. So this times the sides, which is n sides. Okay. So nb. And we see that we have a triangle over here. Okay, 1, 2, and 3, the sides of the triangle. And each time the height, this height gets closer and closer to the radius. As you can see, it's almost touching the circle. And now we cannot even see the difference because it's so, if I zoom in, we can see that it gets closer and closer. If I put like 100 sides, we see that it's very small. We cannot even see. Okay. And so the age gets, let me change color. The age gets approximately equals to r, and the n, oops, the n times b gets approximately equal to the perimeter. And what is the perimeter of a circle? Is the circumference. And we know that pi, okay, pi, that's equal to the circumference over the diameter. So the circumference, that's equal to pi d. Okay. And d is the same thing as 2r. Okay. Rearranging 2 pi r. So nb gets equal to 2 pi r. Okay. So it's going to be n times b, right? The sides times the base, which is 2 pi r, k times r over 2. 2 cancel out. That's pi r squared. Pi r squared. This is the method 1. There is another method. We can take a circle. Oof, that does not look like a circle. And let me go over here. Okay. Now let me do it a little bigger. And so what we're going to do is that right here in the center, we're going to divide it in little circles, very thin circles, okay? And we will have infinitesimal circles, okay? You get the point. So we're going to have little circles, okay? And they are going to sum up the total area. And if we make a cut over here, we're going to have a piece of that. It's going to be something like this. Like here, 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 and here. Something like that. Okay? Let me just try and draw this. Here. Yeah, like this. Okay? And we can say this is a triangle. A rectangle. The length is r. Um, the length is r. Okay. So we would sum these little pieces. Oops. Okay. And the circumference, which is 2 pi. So this is 2 pi r. Okay. We're going to sum this. Or we could just cut it. And they're going to be bigger and bigger. Okay. Bigger and bigger. And if we put this together, bigger and bigger, and here it's going to be smaller and smaller, we are going to get a triangle. Okay. And we know the area of a triangle. Okay. We're going to get a triangle over here with the little stripes there. Okay. You see the stripes? The very, very thin ones. Okay. And so this length over here, that's 2 pi. This over here is r. So it's 2 pi. This is 2 pi r. Okay. Times r over 2 pi r squared. Or we can put this on the x-axis, for example, and we have something like this. And we know this is r, and this is 2. Actually, just think a little bit. We're going to sum the little stripes, okay? These little cuts over here. So yeah, actually, we're going to sum it, and it's going to be r, okay? Here is r, and over here is 2 pi r. So here is r and 2 pi r. And we know that this is going to be a line, and we could make a triangle over here, and we want to know this area. Okay, gosh, we want to know the area over here. using integration, right? If we're going to integrate in relation to r. Okay, what is the function of our line? From 0 to r. Okay, so it's rise, which is 2 pi r, over 1, which is r, 2 pi. So this is the from 0 to r, 2 pi, let's say x, okay, dx. Just to change a little bit. So pi is going to be a constant, okay, 0 to r, to x dx. If we integrate this, it's going to be 2x squared over 2, so it cancels. And it's going to be then pi times x squared from r to 0, okay? So if 0 is going to be minus 0, and it's going to be pi r squared. So three methods. The first one, oops. The first one is this, which is more geometrical. And then we have the one which we cut, and we have this thin stripes, and we sum it, and it gives us a triangle. And the one which we use integration, okay? So these are the three methods.